In Chapter 4, we're going to learn about systems of equations and applications of linear equations. So Section 4.1 is systems of linear equations. So what is a system of linear equations? It's the minimum number of equations required to solve for multiple variables. And the rule of algebra is that for however many unknowns you have, then you need no less than n well-defined equations. So if there are 3 variables, well, then we need 3 equations to solve for all 3. So there are 2 main methods to solve a system of equations. We can use algebra or brute force. This can be done very easily for a small system of only 2 variables. But if you start to get to 3, 4, 5, 6 variables, this can get really cumbersome. Matrix algebra is the most efficient method that will solve for all the variables at once, and we can do this in our calculator. So a matrix is an array of values. It almost looks like a table. And matrices are described by their dimensions. So an n by m matrix has n rows and n columns. So we always say rows first and then the number of columns. If we want to solve a system using matrices, well, we have A is the coefficient matrix. It's all the numbers that go in front of the variables. X is the variable matrix. And then B is the matrix of constants. So we're going to actually show you how to set this up. To solve this for X, right, well, in traditional algebra, we would divide both sides by a variable to get it on the other side. However, in matrix algebra, we multiply both sides by the inverse function, and you have to see that the direction matters when you multiply with matrices. So because this A is to the left of X, I have to multiply on the left by the inverse matrix, which means on the right side, I have to multiply on the left. When we multiply A inverse times B, it produces a new matrix, C, that's the solution to all of our variables. So let's look at how we would set this up for a very simple system of equations. So the first thing that you want to do is rearrange the equations so that all the x terms, y terms line up, and then we have all the constants on one side. So this one's already set up for you, but sometimes you may need to rearrange the equations so that they're in this form. So our matrix A says just pull the coefficients as we see them. So x has a 2 in front of it, then the y has a -1, this x has a 3 in front of it, and our y here has a 2 in front of it. So this is what we mean by the coefficient matrix. So if I take these, and this column represents all the x variables, this column represents all the y variables. So I can just read this matrix, and I know the left side of the equation was 2x minus y, 3x plus 2y. So the signs of the numbers indicate whether we added or subtracted. The variable matrix, we list the variables in a column that match the order that we went across in this row. So if it was x, y, z, this would be x, y, z. All right? And notice here we're calling this x, it's capital X. We use capital letters for matrices. So capital letter X just stands for all the variables, but the variables inside do not have to be named x. Then B is the constant matrix. So we just grab the constants exactly how we see them, and we get a column of constants. So now if I actually want to solve this system of equations, I've got the instructions laid out here on the calculator, but I'm going to walk you through it. If I go to my calculator and I go to second matrix, so on your calculator, matrix is right above the x to the -1 button. So when we do that, I can go over and I go to edit, just like we would in lists, right? We want to edit the matrix. So I'm going to grab matrix A, and this is a 2 by 2 matrix, so rows by columns. So 2 by 2. And now it produces, when I hit enter, the 4 slots that I need. So now I'm just going to enter this exactly the way that I have it. So now if I go back to second matrix, I can actually see that my matrix A has dimension 2 by 2, and so I know it's saved all my values. So now I'm going to go back over to edit, and now I'm going to enter matrix B. And I don't need to enter the variable matrix because the calculator intuitively knows that there are two variables. So I just need to enter my constant matrix, B. So this is going to be a 1 by 2 matrix. Oh, sorry. It's a 2 by 1, 2 rows, 1 column. So let me go back up and change that. And so the nice thing is you can actually see in the calculator that the dimensions should look the way we wrote it. So that was 10 and 5. So now that I've entered my two matrices, all right, I'm going to quit. And now I'm going to go to second matrix. And on the name screen, if I just grab the matrix, it lets me enter it on my home screen. So I want to multiply A inverse, so I'm going to grab matrix A, and then I'm just going to hit the inverse button, which is the same button that matrix is above, and now I have A inverse. Then I'm going to go back to second matrix, and I'm going to grab B. So now it's saying take matrix A, invert it, and multiply it by B. And remember, the order matters here. It has to be A inverse times B. So now my matrix C comes out. And the way you read the solution matrix is we use the variable matrix, and it's saying X is the first value, Y is the second value. So I'm going to round these to 2 decimal places, and the solution of this is that X equals 3.57 and Y equals negative 2.86.